Right, today we're going to talk about some more identities. We're going to talk about the sum and difference identities. In your book, in section 5.6, there is a proof for a couple of these identities. You need to read through the proof thoroughly and make sure you understand it because we're not going to go over it unless you just have questions, and we'll go over that in class. These are the identities, the sum and difference identities, and you need to know these. These, if you just little memory tricks. Remember the cosines go first and the sines go second. And when you have plus or minus, you use the opposite. For sine, we have sine, cosine, then cosine, sine, and then plus and minus stays the same. That's just a little memory trick. How does this help you though? Well, mostly it helps you with things like simplifying equations and putting things together. It also can help you if you need to know the sine or cosine of something that's not on the unit circle. If you can get it as adding or subtracting of things that are on the unit circle, you can get exact values for those. There's also on page 255 a review of the odd and even identities, the cofunction identities, and the period identities that we've done previously, and you need to make sure you review those and know those because you'll have to use those as well. There are a lot of trig identities. Some we went over in 5.5, some we went over in previous chapters, some we're going over today, but you need to know those. Make yourself a sheet that shows all the trig identities that you know so that you have something to study off of. All right, so to use these identities, what are we going to do? Well, let's say I want an exact value of the secant of 19 pi over 12. Well, I know that means 1 over the cosine of 19 pi over 12, but I'm not really sure what that is. It's not on my unit circle, so how am I going to find an exact value for that? Well, if I look over here, let's think about 19 pi over 12 for a minute. 19 pi over 12 is 21 pi over 12 minus 2 pi over 12, which is 7 pi over 4, which is on my unit circle, and pi over 6, which is also on my unit circle. So I can use that information to give me an exact value. So this is the same thing as the cosine of 7 pi over 4 minus pi over 6. Now I can use my identity, and I've got 1 over the cosine of 7 pi over 4 times the cosine of pi over 6 plus the sine of 7 pi over 4 times the sine of pi over 6. So what is that? Well, cosine of 7 pi over 4. 7 pi over 4 is in the fourth quadrant, so that means my cosine is positive and my sine is negative, and the over 4s are the square root of 2 over 2. And then pi over 6, we know that the cosine of that is the square root of 3 over 2. Now, remember we said this is 7 pi over 4 is in the fourth quadrant, so the sine is negative, square root of 2 over 2, and then the sine of pi over 6 is 1/2. If you don't know that unit circle yet, another thing you've got to be working on. So now we just simplify. We've got 1 over the square root of 6 over 4 minus the square root of 2 over 4. So they're both over 4, which means that we can pull that up top. This is algebra stuff. If you're having trouble with it, you need to come see me so we can go over and make sure that we have all those algebra things down. Now, personally, I'm okay with you leaving it like this, but when you go to check it in the book, that's not the answer they're going to give you because they don't like having these rationals in the bottom. And that's just a personal preference, I think. And so you need to know how to rationalize these things, but it's not always necessary. I want you to go ahead and do that though, just to get practice. So in order to rationalize this, we got to multiply by something that's going to get rid of the radicals. So that means you do the same thing but with opposite signs. So we end up with 4 times the square root of 6 plus the square root of 2 over when you multiply this out, you have to FOIL it out, remember. You end up with 6, and the middle parts cancel, minus 2. Well, what's 6 minus 2? 6 minus 2 is 4, so that means that's going to cancel with the top. So we end up with the square root of 6 plus the square root of 2. Do I want a decimal approximation? No. The whole reason we went through this was so we would get an exact value. So this is your answer. Exact value. All right, let's try one more. What if I want to know what the tangent of 5 pi over 12 is? Well, I know my unit circle goes with sine and cosine. So I'll switch that to sine and cosine. But 5 pi over 12 isn't on my unit circle. However, if I look at it, 5 pi over 12 is 3 pi over 12 plus 2 pi over 12, which is pi over 4 plus pi over 6. And that is on my unit circle. So, again, I use my sum and difference formulas so that I can figure out an exact value for this. So on the top I get the sine of pi over 4 times the cosine of pi over 6 plus the cosine of pi over 4 sine of pi over 6 over cosine of pi over 4 cosine of pi over 6 minus sine of pi over 4 sine of pi over 6. All these are values you should know from your unit circle. Square root of 2 over 2 times square root of 3 over 2 plus square root of 2 over 2 times 1/2 all over square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. Now if you notice, we've got 4 as our common denominator on both of those. When using your algebra, you'll see that those 4's cancel out. So we're left with the square root of 6 plus the square root of 2 over the square root of 6 minus the square root of 2. Again, I'm okay with you leaving it this way, but your book wants you to rationalize it. So that's what we're going to do. Square root of 6 plus the square root of 2 is what we need to multiply by to get the radical out of the bottom. So we multiply that out, and if we FOIL the top out, we get 6 plus 2 times the square root of 12 plus 2. And then on the bottom, we end up just like we did last one, where we get 6 minus 2, which is 4. Make sure you know how to do that. I'm skipping steps, assuming you know your algebra. So on the top, we end up with 8 plus this radical simplifies to the square root of 12 is the same as 2 times the square root of 3 because 4 times 3 is 12. So we end up with 4 times the square root of 3 because we've got that 2 already out there over 4. So that simplifies to 2 plus the square root of 3. So that's our exact answer. Again, do I want a decimal? No, I want an exact answer, this one. Let's try another one. What if I tell you that the sine of x is 3/8 and the sine of y is 2/3 and x is in the first quadrant and y is in the second quadrant, and I want to know what the cotangent of x minus y is. Well, the cotangent is cosine over sine, and we know our formulas. But here's our problem. They only give us the sines. They don't give us the cosines. But do we know how to find those? Well, of course we do. X is in the first quadrant, and we know that the sine of x is opposite over hypotenuse. So we can use our Pythagorean theorem to figure out that this leg is the square root of 55. Then we know that this one, so that tells us that the cosine of x is the square root of 55 over 8. Now for this one, we know it's in the second quadrant, and sine is opposite over hypotenuse. And we can use our Pythagorean theorem, and we know that this has to be the square root of 5. Because we're in the second quadrant, we know it has to be negative because our x value has to be negative. So that means the cosine of y is negative the square root of 5 over 3. So we have all our information now, and we just have to go up here and plug it in. So cosine of x is the square root of 55 over 8. Cosine of y is negative the square root of 5 over 3, plus the sine of x is 3/8, and the sine of y is 2/3, all over sine of x, 3/8, cosine of y, negative 5 over the square root of 3, minus cosine of x is the square root of 55 over 8 times the sine of y is 2/3. All right, now again, we've got a common denominator here of 24. It's on the top and the bottom. It'll cancel out. So we end up with negative square root. Now this one, I'm not going to multiply 5 times 55 because I know that 55 is 11 times 5. So here I see I'm going to be able to pull this out of the square root. So there's no point in multiplying it out. Just causes extra work. And so then we just multiply like that. So we end up with negative 5 times the square root of 11 plus 6 over negative 3 times the square root of 5 minus 2 times the square root of 55. Now, again, I'm okay with leaving it that way, but your book was going to want to simplify it, and it's going to take us some space, so we're going to erase this over here. We're going to have to rationalize the bottom, and it's harder to do with both those negative signs there. So the first thing we want to do is get rid of some of those negative signs. So if we factor out that negative sign there, then multiply it up to the top, we end up with 5 on the square root of 11 minus 6 over 3 on the square root of 5 plus 2 times the square root of 55. So we factored out this negative and multiplied it up to the top, which changed the signs in the top. Now, to rationalize it, we've got to multiply times 3 root 5 minus 2 on the square root of 55 on the top and the bottom. Remember, whatever you do to the bottom, you got to do to the top. And you end up with a big long mess. So we multiply this and we get 15 times the square root of 55. Multiply this here, minus 10. Now, again, I'm not going to multiply this out because I know that 55 is 11 times 5. And so if I just write it that way, I'll know I can pull my 11 out. Minus 18 root 5 minus, or plus, negative times negative, 12 times the square root of 55. Make sure you're checking me for careless mistakes. You know how famous I am for those. Over, and on the bottom we're going to have 45 minus 220. Okay, 3 times 3 is 9, times 5, 45. 2 times 2 is 4, times 55. All right, so on the top, we've got 15 and 12, so that's 27 on the square root of 55. Now this one here is going to end up being 110 on the square root of 5, because we pulled that 11 out. So when we combine that with this other square root of 5, we end up with minus 128 on the square root of 5 all over negative 175. Now, just to make it prettier, this negative sign down here, we could get rid of that by multiplying it up here. And we end up with our answer of 128 on the square root of 5 minus 27 on the square root of 55 all over 175. Now, do I want decimals? No, I want the exact answer. Do I care if you leave it over here? I'd rather you go ahead and try to rationalize these for now. This is okay. It's a perfectly acceptable answer, but I need you to know how to rationalize them in case you get somewhere where you were expected to, and also so you can check your work in your book. Make sure you know these identities, these sum and difference identities, and how to use them. Go back, make sure you make yourself a trig identity cheat sheet. You are going to need it, and it's going to be something that you're going to need from now on. Make sure you've read the section, and we'll work on it in the next class.